since Sam is here. All right, on to the RADOS tail latency improvements. Since you're already here, Sam, you want to give us a rundown of the blueprint?
Sure. Okay, so this is a couple of things that have been proposed for reducing latency on the slowest IOs. So just tightening up the distribution so that IOs generally happen faster. One of the problems is that an OSD, when it asserts, goes through the same sort of failure detection as a host physically dying. And we can do a little bit better than that. We don't actually need to wait for the cluster to detect us as down, go through the heartbeat timeout process, everyone report to the monitors decide that enough reporters have reported, publish an OSD map marking us down, and finally we can start doing IO somewhere else. That process takes like, 30 seconds or something. So if we're going to fail an assert because of an EIO or because something bad happened in the software, we could instead do the same thing we do in the graceful shutdown case, which is send a message to the monitor on the way out saying, I certify myself as being dead and I will not respond to any further messages. That allows the monitor to mark it down without waiting for reporters. So that would be a small but very tractable change that someone could do. So there's going to be a later session on some peering speed improvements. So I'll just summarize that as there are some peering situations we can do with fewer messages than we currently spend. So, well, actually, is that the next session? Lobby reads. No, for some reason it's the one after the break. Okay. So the big one though is automatically detecting slow OSDs. If you're used to running a decently sized Ceph cluster, you'll notice that if an OSD gets slow, the whole cluster will tend to slow down to that speed because Crush is partitioning data based on whatever static weight you gave it, not based on any kind of real-time evaluation of the OSD performance. That part probably can't really change because you don't want to be dynamically moving data around, just because an OSD happens to be a little slow right now. But we might want to shift primariness away from such OSDs, and we might want to preemptively mark them down if we think that the slowness is possibly a symptom of a failing disk. There's also a patch out to read, I don't know if anyone read the Yahoo, I think, paper, but for an EC pool to read all of the chunks and use the fastest K return chunks to reconstruct the read. And they found that there was a pretty substantial improvement. One of the problems is that it still goes through the primary, so if the primary is slow, it'll still be slow. It doesn't really add a benefit for writes, and there's nothing analogous we can, well, I guess there really isn't anything analogous we can do with a replicated pool. By the time the primary has gotten around to processing the message, it's a fair bet that it's faster to go to the file store, even if it is under load, than it will be to go to the replica. One way around that might be to concurrently read from the client from multiple replicas. I'm working on some patches to make replica read work properly, so it wouldn't be a large step from that to being able to at the client read from all of the replicas and use the fastest response. So this blueprint was also in the previous CDS, and not a lot of work has happened yet. So I guess we're looking for volunteers and feedback. Okay, so that's the summary of the blueprint part. Does anyone have any comments, feedback, questions?
Looks like Mark had a question there.
I think except the slow disk reason, we found most of tail slow requests come from the fast door internal implementation because something like PG thread to read object info, it will look up multi-inode from disk, and we found at most it using nearly 500 milliseconds to read inode to complete the read object info request. So except the slow disk problem, I think maybe we could delve more focused on something like this, like object store itself, like a fast store. Do we have any solution about this?
Well, that is, Sage is actively working on the replacement for the file store. So it's true, the file store could be faster, and we're going to fix that also. Do you feel that this is causing just generally slower reads, or a big spike in 99th percentile reads? That is that is the slowest reads are much slower than the average case. Do you have a sense for which of those is true?
Yeah. Could we consider to increase the file per dictionary? For example, we could at first open 4 dictionary. As we know, by default, 8 dictionary depths is the max, and we can open 4 depths file dictionary at first. Then we can do search from above or behind.
I'm sorry, I don't quite understand.
Yeah, this is a little related to how the hash index do the lookup.
Yeah, sure. Yeah,
Yeah.
no. So I'm asking, is it your feeling that this means that all reads are slower, or that some reads are much slower than the average?
Yeah.
Both?
Yeah, both.
Okay. So if it actually is the case that the object store itself has an extremely large read latency distribution, then we could get some benefit by sending the read in parallel to the replicas from the primary. So that would be an interesting approach. As far as actually improving the file store performance, we may not choose to do that. I think what we're going to choose to do instead is rewrite it. Much of the complexity in the file store comes from trying to use the file system directories to facilitate collection listing, which wasn't a good idea as it turns out. That's why we have the hash index, and that's why we have to do all of those directory traversals. So it's unlikely that while we could probably make the existing implementation better, it would be better to not have to do that in the first place, which is why Sage is working on new store.
I know. Yeah, I know.
Okay. So what were you saying?
No more. Yeah, I just come up with the common questions, and I don't have too much sense to how to throw it before you store it.
Do we have any other questions, comments, observations?
Comments in the questions in the chat here.
Hey Sam, can you hear me?
There.
Oh yeah. Oh, I was looking at the wrong one. Sorry, I was looking at the Ceph Summit IRC channel. Let's see here. How will an OSD mark itself as slow? So that is one way it could do it. That's a little bit tricky because it needs to know what the other OSDs consider to be a normal throughput. Just a quick thing. Guang, I was talking about replication in that case. Doing it for EC is harder because the client needs to have access to the erasure coding library used, which isn't impossible, just harder. So that would be different. The client is already capable of performing replicated reads from the primary, or from replicas. It's just that there are holes in the implementation that make it not a good idea to use in the general case. But once that's fixed, which should be relatively soon, it wouldn't be difficult to add a mode to the client where it reads from multiple replicas at the same time and uses the fastest one. So let's see. As far as marking itself slow, it's odd because you could also have multiple classes of OSD. So we'll have to make it as we'll probably have to create some kind of a process where the OSD benchmarks itself and stores what it believes its speed to be, and then over time it would be able to detect the degradation, perhaps. I'm not sure. We'll be looking for input on that certainly. Do you have any thoughts?
Sam, can you hear me, Sam?
Yeah, I was going up instead of down. I probably should have.
Oh yeah,
down.
no, that's fine. I wanted to make sure you could. So on this topic specifically, couldn't we take a look at statistics regarding things like the I/O size and the throughput, and kind of get a general sense of what we think the backend is? You know, there are certain classes of drives, right? Like 7200 RPM drives that have fairly consistent performance characteristics. We might be able
Are
to
are they that uniform? That's what I'm wondering.
Well,
basically,
you know,
I'm wondering whether we can afford to assume that there are sort of fast SSDs, slow SSDs, and spinning disks, and whatever you are, you must file into one of those performance regimes.
Yeah.
Is that what you're talking about?
Yeah. So I mean, SSDs are definitely harder. Spinning disks, we could probably get away with it, I think, but probably not with SSDs.
I don't know, but even spinning disks, if you have an over-provisioned data backplane,
yeah,
I mean, you could get weird stuff, and I don't know.
Yeah, fair enough.
I mean, we could make it so that the user needs to like add this as metadata they put in for the OSD and compare against that, and we could give them guidelines. But even that
I
seems
suppose
low.
that would. Yeah.
Mostly because I don't want to give users the power to input the wrong thing.
Sure. I mean, I suppose you could look at historical trends, right? Because you both want to know, like, what the SSD has done and what it is current, or not SSD, but the backend has done and what it currently is doing.
How might that's a little bit. Well, actually, let me get prioritize primary request to an OSD. What do you mean by prioritize?
Yeah. I mean that if we have four very large write and we have a small IO write, and it is come into the diagonal queen at the same time.
Yeah. So you're afraid that the small write will wait behind the big one, right?
Yeah.
So that's
we
actually that's possibly a feature, not a bug. For one thing, RADOS already limits the size of objects you can have, so you can't have a 1 gig write and a 1 kilobyte write. You could have a 1 kilobyte write and a 4 megabyte write.
Yeah.
And I would argue that the sizes you naturally want your RADOS objects to be are such that you wouldn't want to break it up because it'll be dominated by the seek time and not by the throughput part. So if the large write got to the journaling code first, then it's unlikely we want to break it up. It's likely that we want to simply finish it.
Yeah.
And the part where it actually applies it to the file store generally will happen in parallel, and the file system will get to schedule it.
Yeah.
Or concurrently, not in parallel. Well, whatever. Depends. And Mark, what did you mean by prioritize primary request to an OSD?
So at the time you were talking about potentially the issue of a primary being slow, still even in the case where you have like you're grabbing you're grabbing all of the erasure code chunks and trying to just use the most low latency ones. So I was wondering, in a case like that, does it make sense when OSDs are backed up with a ton of stuff to try to give priority to things that are potentially you have all of the other pieces too that you need?
Well, I guess there are really only two kinds of request. There's the kind that comes from the client, where you haven't committed locks or serialization resources yet, and then there are requests you need to complete as soon as possible. That would be requests from a primary or from the replicas back to the primary that you've already committed resources for. So no, you would always prioritize requests from the primary to an OSD. You would never prioritize the client requests over those, because the requests from the primary are client requests, but they're super client requests. They're client requests that are blocking other client requests. Is that what you meant?
Possibly. I'm trying to parse exactly what you just said.
Sorry, what I mean is, so for a write, for example, when you receive the client request, you send off some subops to the replicas.
Mm-hmm. Absolutely, yep.
The replicas then send back subop replies, which you then process through the same queue, and then you send back to the client an op reply. The first one has the first original client request has a priority of 63, which is the highest non-strict priority. Everything after that has a priority of highest or something. They always prioritize ahead of client requests that haven't been seen yet, because a client request is actually blocked on them, and furthermore, we're holding a lock. So once we've decided to...
When you have a situation where you have requests at the same priority level, how do they get ordered?
It's round robin among the clients that sent them.
Okay.
Does that make sense?
Yes.
Okay. Yeah, it seems like you'd want to prioritize client requests over requests from other OSDs, but the requests from other OSDs are almost always on behalf of a client request. So you want to do those as soon as possible.
Yeah, I think in my head what I was thinking is, okay, assuming that we have all of the subop replies come back into the primary for like an erasure coded object, presumably then as soon as that happens, you'd want to send off the response back to the client, maybe over dealing with other things, but I'm not sure if that actually makes sense or not. That's kind of where I was.
That's what we do. The individual messages that come back from the replicas are all high priority. We would rather work on those than on new client requests.
Okay. Cool.
Whenever possible, we'd like to work on completing a client request rather than starting a new one.
Yeah. I was thinking in your case where you said that if the primary is slow, what is the way to kind of mitigate that as much as possible?
The only way the only way to really mitigate that is either to reduce the work the primary is doing, period, which means not sending the request to your own store, but sending it to a replica instead, or sending it to both and using the fastest return. That, by the way, doesn't make the primary any less slow. It just means that the client doesn't see it. It actually increases overall load. Or the client could send it from the client to multiple replicas and use the fastest return. Which, again, same thing. It doesn't make the primary any less slow, but it does mean the client is less likely to see it.
One thing that I've toyed with in the past, which I don't know if it's even worth getting into here, is the thought of having some kind of local decision-making process if a particular disk is slow, having an OSD be able to potentially kind of spill over to another one, but it's kind of it could all probably happen right below Ceph, not even have to have Ceph involved. But
we can do it above Ceph, actually. And that's so there are two kinds of things you can do when you have a slow disk. You can do things that require a lot of effort and things that require a very small amount of effort. Things that require a very small amount of effort include letting someone else be the primary for your PGs, and we have we have machinery in the monitor for that. The primary affinity, you would set your primary affinity to 0. You would still hold the same data, so you wouldn't shift any data, but Crush would tend to output a different one of the for all the PGs you're in the acting set for, a different OSD would wind up as the primary, so you wouldn't see read requests. That's the kind of thing we could do. What am I looking for? Quickly, as in response to transient shifts well, somewhat quickly, in response to relatively short transient shifts in slowness, perhaps because an OSD is overburdened for a while, because it doesn't require data movement. But if we see a longer term trend, let's say on the order of tens of minutes or hours, we could start to dynamically lower the OSD's weight and move data off of it. And I think that's the other direction we'll have to go to eventually. That's it kind of has other nice properties because SSDs will tend to degrade as they run out of working space. And you actually want to move data off of them anyway because you want to give them more space to use as whatever the hell SSDs do. So that might be a really interesting direction to explore.
So the reweighting though only helps on assuming that you don't have lots of pools, right? Because once you have lots of pools, potentially you've got like a lot of you no longer have uniform skews. The skews start getting kind of random, so you don't gain much by reweighting.
As long as
every
all of the
pool is being...
as long as all of the pools have uniform distribute, or as long as your I/O is partitioned all over your pool such that it's uniformly distributed over the PGs, then it still works. The problem you get into is when the pool that receives all of the I/O doesn't have enough PGs, and then that's not a skew problem. That's simply you don't have enough PGs. It's not that you don't have too many pools. It's not that you have too many pools. It's that you don't have enough PGs in the pool that's receiving all of the I/O. It's that your I/O and data needs to be well partitioned over placement groups.
Mm-hmm.
Assuming you have the hash PS pool parameter set, of course.
Yeah, oh, that's a separate problem, but yeah.
Any other questions? Comments? This is kind of a big area. There are lots of ways we could consider doing the OSD speed thing. It's going to be kind of a lot of work, and the nice thing about it is that it's not that internal to the OSD or the monitor. It'll be in the code, but it'll be a new chunk of heuristic that will only interact with the existing code minimally. So this would be a pretty good project for someone who had a good design they thought might be worth implementing. It'd be pretty easy to prototype also. Do we want to move on to the next one?
Sure, we can do that.
Or do we want to let the schedule catch up a little bit?
Yeah, as I say, we're 20 minutes early now.
We can, Sam. I'm sure we could fill the dead space with random conversation about performance. I'm cool with that if you want to. So Sam, in terms of long tail latency, I mean, what do you see as being the kind of the biggest things that are hurting us right now in the OSD?
Probably that recovery, scrub, and snap trim run in their own, used to run on their own pthreads. As of a couple of weeks ago, scrub and snap trim have been moved into the main priority queue, and I have a branch that does that for recovery as well. So that should help a lot, because before we were relying badly on the pthreads, on the OS's own scheduling to decide when we were going to do recovery versus when we were going to work on client I/O, and that was never all that good an idea. So I think we'll get better performance under contention once people start testing out those changes. After that, it'll be, I mean, as Hamai is pointing out, the file store is incredibly complicated in the number of things it needs to do to complete a read, and that's not great. So new store is going to help a lot there. Although, Mark, you're in a better position to tell me whether that's likely to help, I suppose.
We are seeing that. Actually, interestingly enough, with large IOs, with like large sequential reads, new store is significantly better than file store. The place where new store really falls apart is on RBD overwrites, or not RBD, but just on object overwrites in general, like large object overwrites. So that's kind of what we need to focus on there. But in a lot of other cases, actually, new store is looking really good.
Cool. Has it wound up
definitely...
reducing CPU usage a lot?
You know, I've got data. I haven't looked at it. I should go back and do that. So I don't have an answer for you right now on what the CPU usage looks like. Although I suspect that it's from a performance perspective, it's no worse. This machine that I've been doing testing on is not super fast in terms of CPU, and new store does better. Maybe one question here would be, so like both in the file store and with new store, you know, the level DB or RocksDB or whatever we have for the key value stores is kind of becoming more important, and latency is a really big deal, especially during compaction. So that's in terms of like reducing our long tail latency. This is an area we probably need to be thinking about more and more going forward.
You're saying that when RocksDB is doing compaction, we see latency spikes during lookups?
Absolutely, and LevelDB is worse.
That's distressing.
Yeah, I have the idea. Could we reduce the number of pglog at the normal state, such as by default it is 1,000 pglog, if I remember correctly. So we can make pglog buffered at level dB write buffer. Default is I think is 8 MB, and we can let all pglog state at a journal and don't flush into disk. So maybe we can reduce some pglog writing.
Yeah, that probably wouldn't hurt. You can so the number of pglog entries that are configured is not a magic number. You need enough so that you don't spuriously go into backfill when you reboot a host. Beyond that, I'm not sure it matters that much. You could also tweak the level DB settings so that it's caching a much larger amount, which would be a good idea. Nothing magic about level DB settings either. In fact, if you can make an argument that we're simply using the wrong settings, we'll probably just merge a change to the defaults.
But from perf, I found many CPU busy time is consumed by LevelDB to merge and look up and others. Maybe we can merge this at fast store or LevelDB store, and maybe something, and we can reduce LevelDB CPU usage.
Actually, another option, something you want to try is try running RocksDB under the OSD instead of LevelDB. I believe there's a way to configure it. I don't remember what it is. Don't run new store, run file store with RocksDB and not LevelDB. And see if that helps. That's one of the things that RocksDB is specifically supposed to do less badly.
I don't use RocksDB. I'm use LevelDB.
Yeah, so I'm saying that they're very similar in many ways, and that they descend from the same code base, except that RocksDB is specifically designed to help with that. That's one of the things they put a lot of effort into improving.
Okay.
So you may find that problem simply is no longer a big one.
I don't remember if LevelDB gives you statistics like this, but with RocksDB, if we run the OSD using RocksDB, it will give us kind of semi-regular statistics on kind of what data is hitting what level and kind of the size of the key value pairs and all this other stuff. Do we have a good sense right now on kind of what the workload looks like from the OSD, or are we kind of in the dark still?
I think we're still mostly in the dark. How that would be a good thing to look into.
Yeah.
Sam, do you know, have we seen any evidence in the recent past that LevelDB is causing any kind of like latency or other issues in the OSD? I remember kind of looking at this like a couple of years ago, and I didn't think that it was, but I'm now questioning myself a little bit.
I don't think that it is either, but then again, you weren't testing with SSDs at the time, so it may be that with faster storage, the CPU problems start to become more obvious.
Yeah.
I don't think it's the overriding problem with the file store because of how wasteful we are in the file store generally.
Mm-hmm.
But I don't really know, so that would be a thing to look up.
Sure.
Okay, shall we move on to sloppy reads, or do we want to wait for 10:30?
No, it's fine. We can move on. Hang on, let me just switch it over.